Hey everyone, and welcome to this video where I'm going to be taking you step by step through how and that can be applied to anything. We're at the precipice of this kind of system. RAG tutorial videos are popping up all over the internet. N8N has made a lot of tutorials about it because it's, I think, principally N8N and maybe LangChain and LangFlow are like the two big contenders at the moment for making these kind of systems. I'm loving N8N because I know it already, and I'm not really that much of a fan of LangFlow because it's a bit too codey for me, and I'm still more on the no code, low code side than the code side. So if you are watching this video, I hope that you're at least can appreciate how the advantages of using low code solutions. But if you're already coding things by yourself, then this might not be interesting for you. But I think the concepts are still worthwhile. Whether this is coded or low coded, the basic concepts of how this RAG model works, it's still applicable. So I think a lot of people could get a lot out of this video. So the concept of this is today you can install your own AI chat assistant with, for example, Ollama is what I'm using. But it could be you're using your own local implementation of Hugging Face with your own preferred model or whatever. I just find that Ollama is incredibly conversationally good with a very low RAM count. So I'm on like 2 gigabytes of RAM just to run it. I think it peaks at like 8 gigabytes of RAM when it's really working hard. Obviously it's just for me, so this isn't applicable if you had a lot of people questioning the server at the same time. You would need a lot more RAM than that to run concurrent questions, concurrent completions. But for testing and just learning how the system works, I think it's fabulous. You can install it for free and it's really easy to set up. I'll put links to guides in the description. And the stack that I'm running for the RAG model is N8N to handle the workflows, MinIO to handle uploading, and I'll explain that in a minute, and Quadrant, which handles the vector storage for the chatbot. So Llama, N8N, MinIO, and Quadrant, and that's all you need. So I'm running these three in Docker, and I'll maybe post a link to the Docker compose file that I use for these. And Ollama is running locally because it doesn't play very nicely on Mac in Docker. So it's better to run it on the Mac directly and have the Dockerized, containerized services communicate with Ollama outside. So the first step to making this work, let's just explain first the project that we have. This could be for any kind of business, but obviously because you're watching one of my videos, it's going to be about cats. And this one is going to be, I'm imagining that I'm working for the US Department of Agriculture and I'm a civil servant, and I have produced this 25-page document about free ranging and feral cats. And I know for a fact that basically nobody's ever going to read it. So that's one particular use case where you're producing documents, no one's ever going to read it. They would much rather talk to Alex Dutcher or Kyle PS, however you pronounce that, to talk to them directly. If they have some questions about feral cats and free-ranging cats, I'm sure they would rather go and talk to these dudes directly and ask them questions about it, rather than reading through this whole 25-page document to try to understand if you have feral cats in your field or something, to know why that's happening or what you should do about it, and what the law is, etc. So this is one of those cases where you've got a long document that that customers aren't going to read. Imagine in the case that you've got terms and conditions. Nobody ever reads your terms and conditions. Well, what if you could take documents like this and have a chat assistant work exclusively on those documents to provide answers to your customers' questions? So when they come to your website thinking about terms and conditions, they say, what happens if I cancel my contract early? That the chat model can actually find the relevant part of your document, no matter how many documents you have or how long they are. It can find what's needed to give the answer. And why? So the first question would be, why vectorization and this whole RAG model, rather than just uploading the documents directly to your own custom GPT, for example? The issue with a custom GPT or other kind of model, Claude projects or whatever, is that you're sucking up a part of the context window. So say you've got a context window of 100,000 tokens or whatever it is these days. Or when you're watching this video, it's probably 1 billion tokens in 2 months' time by the time it's already progressed. But you're already sucking up a lot of that token window with this really long document. And I imagine you had not just this document, but imagine you had 20 documents of 25 pages. So you've got like 400 pages worth of stuff. That's a lot for the context window. Are you really willing to pay that every time a customer asks a question, you're taking up already 50,000 tokens just to digest your PDF every time the customer asks a question and starts a new conversation? That's obviously really inefficient. What vectorization does, and what RAG models do, is it takes the document, it breaks it up into chunks, which is this part here, which I'll talk about in a minute, and then stores it in and vectorizes it with an embedding model. So it turns it into numbers. So no matter what it is, no matter what language it's in, whether it's text, audio, image, whatever it is, it gets turned into numbers, into vectors, stored in a special database, which can very, very quickly be queried by the same model or similar model. That can ask, hey, do you have anything that's similar to what my query is in terms of vectors? So somebody's asking about feral cats, and they're asking the specific question, do you have anything in that vector base that has something close statistically, numerically, to what this person is asking about? And so it's not searching through the words, it's not trying to understand the whole document. It's actually just pulling out, say, 10 results from this document, maybe it's 10 paragraphs, that mathematically corresponds to the vectors of the question. So I'm not good at maths, and I don't really understand how that works exactly, but I know that it's trying to place a point on a 3,000 axis graph that shows what this particular chunk of information represents numerically. And then when the same model asks a question about feral cats, what do I do if they're in my garden, then the same 3,000 axis point should be very, very close, like say 95% similar to what the chunk of information is. And so that chunk of information will come out, or the top 10 chunks of information will come out. So you're only, instead of a 200 pages of documents, you're only pulling out 10 paragraphs out of all of it. And it means that you can have a vast, wide-ranging load of information. Like you could have a Excel document that has sheet after sheet and line after line, millions of lines of data. And you can query and just get a couple of them back that particularly correspond to what the customer is asking and not have to waste tokens on the whole document. So it is definitely the right decision if you have a lot of data that you're trying to get the chat model to work on, to give its answer based on that data. If you've just got like a 2-page PDF, then sure, upload it to ChatGPT. It's like whatever, 500 tokens, no big deal. But this is the case where we have larger documents or very large data. It could be databases as well. You can vectorize anything if it's necessary. A database, and that's the other question, is why not just use a database? That's the big RAG question, is what's the difference between using RAG and a database? RAG is, a database would be if you have structured data. So if I have 500 rules that you need to take care of, or you need to keep in mind about cats in your land when you're living in the countryside in America, and it's organized into columns like should take the cat inside, yes or no, should feed the cat, yes or no, should, and then it's like different cases, like the cat is a ginger cat, the cat is a big cat, the cat is a small cat, and then it's like yes, no, yes, no, yes, no. Then that's structured data. So I can say, show me all the cat breeds where I should not take them inside my house. And then it can query the database and say, everywhere where the column should take into the house is false, give me those results. That's a structured query where you have a structured database. Now, in this case, most likely where you have a document like this, which somewhere in the document explains when you should not take an animal into your house, then that is, you're not going to be able to structure that data. That's more vectorization. That's going to just need to be translated into something that an AI can understand, that an LLM can understand, to return the data that you need. without having to think of a way to put it in a big Excel file in a database. And I also think it works really well for anything that's like here, for example, where I live. I'm thinking about local restaurants where they maybe have recipe sheets and allergen information and opening hours and holiday days that they're not open, and reviews from customers, and etc. etc. That all of this is not structured. You can't mix reviews with customers with a recipe sheet. That doesn't go in the same database. That's just two completely different things. Maybe two different tables, but again, like you can have like review stars 4, stars 5, stars 3, and that's structured data. But the actual review part of it, you don't know what the customer is going to write, so there's no way to structure that data. So in that kind of case, you just dump it all into a vector database, and then the customer can just ask, if you're wondering whether you should come to our restaurant, just ask here. The friendly chat assistant will tell you, the friendly chef will tell you. And the customer asks, I'm allergic to shellfish and gluten. Is this a good restaurant for me? And the system can come back with yes, because we have this and this and this meal that corresponds to what you like to eat, and it doesn't have gluten, doesn't have shellfish. And also there are several customer reviews saying that they were allergic to shellfish and they've never had a better meal in their life, and so this is a really good idea for you. And so that the assistant is taking over from what I said before. The Alex Dutcher doesn't have to take phone calls about this document anymore, because he has a RAG assistant that's doing the questions and answers. The restaurant doesn't have to take 20 phone calls a night asking about if they can have a reservation and do they have shellfish in their food. The RAG assistant can help, but obviously that example's maybe very specific, because if the RAG assistant makes a mistake and the person comes and like gets an allergic reaction, then that's risky. So let's remain realistic about it, but it still presents an amazing opportunity for anybody who's everybody, I think anybody who runs a business and has contact with clients or otherwise. I could go on all night. And I'm not going to. I'm going to show you how it works. So let's chapter this video so that you don't have to sit through the entire spiel at the beginning. But I do think it's eye-opening when you start your brain thinking about it. And I hope that I've started you thinking about it, and you're going to be thinking, oh my goodness, my local business who never wants anything to do with IT stuff, if I go to them with this idea, they're going to flip their lid. And I think it's a great opportunity. So without further ado, how does the RAG system work? In my system, I'm using uploaded files. So I'm imagining you're going to be using PDFs or doc files or Excel files, or maybe even like your website. Maybe you want to like download the About Us page from your website and use an HTML document, for example. You can use anything you want. What we need to do is upload it. Now, a lot of the videos online are going to tell you in the tutorials that the way to do it is to connect your Google Drive or your Dropbox or something like that. Dump the files in there and then upload them. While that could be a good idea, and especially quite handy for the client, because then the client you can share the folder with them and they can dump the files in there, and you can have like a detector that says when a new file is added, then do the workflow. But that's not what I'm doing here, because I tried to do that, and because I don't have a Google Workspace account, it seems that I can't create an OAuth, because you need to have OAuth if you want to add Drive to this. Then you need to say you want to do a search, or you want to trigger, so you want to see when something changes in a folder. Then you need a Google Drive account, and that requires OAuth. Now, on localhost, it just doesn't work, first of all. And second of all, the whole client ID, client secret thing, if you're running an external app, you can do it in testing mode. So you could like add your email as a test user to the OAuth system that you're setting up, and the client's email as well, for example. But it'll throw up like, this is dangerous, this is a test thing, proceed at your own risk. So it's a bit off-putting. So I would say the OAuth thing, if you were to do it in production and have people actually authenticating with Google to get in here and add their own files, it's a pretty big pain in the butt. But I think this is mainly if you want to do it in N8N, then you are assuming that you're going to be doing it with your own Google Drive, and then having maybe customers, your client, upload their files into the Google Drive. Anyway, I found it to be really complicated to set up the OAuth. and restrictive. I didn't want to have to fill out a whole application to Google because I'm doing a restricted scope, which is accessing Google Drive. So forget about that. I decided I'm just going to use the standard S3 bucket instead. And the super easy way you can get files from your computer into a bucket, which is what the customer is going to say. They're going to say, hey, I've got like a folder with 2 gigabytes of recipes and customer reviews and all this stuff I've downloaded for you. I've got it all ready. What do I do with it? Then we're going to set up a MinIO instance. MinIO is an S3 compatible storage service. And so it's very similar to something like Amazon S3 or Google Cloud Storage. And you can set up a bucket. So I've set up a bucket called ragtest. Go in and make sure that it is, I think it needs to be public. I can't remember if it needs to be public. No, it doesn't need to be public. I think I just did that for testing, but public access is when you want to, where's the options for that bucket? When you want the files that are in here to be publicly accessible, so that when, for example, say your chat returns a file name, like a file, maybe it returns like a URL to the file, that if the user clicks on that, they would be able to access it within the MinIO storage. So that might be something you want for your app, for customers to be able to find the document that's actually being referenced, if you have loads and loads of different documents, for example. But in this one, I don't actually need it, so I'm just doing it. I just did it for, in case that was one of the things that was blocking it. But that's pretty much all you need. Have that set up and then upload your file, whichever file or files that you're going to upload. So it's this one. And so, I mean, I'm uploading that locally. It just means that I can then bring that into N8N, which is where I want it to be in the end. So I've got the document that I want. I've told N8N that I want to search MinIO, so I've set up the MinIO credentials. Because they're running in the same Docker container on the same network, you can reference it with, instead of localhost.9000, which is the port that MinIO is running on, you can actually reference the service name, which is MinIO 9000. I say you can, I mean you need to, because they're running on the same network. Region doesn't matter because there are no regions in MinIO. Access key matters, so you can go and create your own access key here. And it'll give you the key, access key name and secret key pair, and you don't need to worry about anything else. Pump that in here. Force path style is important, I think, because it's not a real AWS bucket, and ignore SSL just because we're not going to be using any security. We're here on our local server at the moment, on our local machine, I mean. So we say that we want to take stuff from a bucket. We could also say that we want to grab a file. We're going to search for anything that's within that bucket. So we give the bucket name and we want all the results. In the end, there's only one file, but I'm running under the assumption that you're going to create a folder and then either yourself upload files into that, or let your client upload files into that folder. Then afterwards, we download the file. So we take the file key, which is one of the parts of the result, and we download that file and output it as whatever data, or you can put files or whatever. So it's going to do, say it returns 5 files, it's going to run that 5 times. I've got a little code that ChatGPT drummed up for me, which detects the file type. So does it switch and says, like, if it's a PDF, then output PDF, if it's CSV, output CSV. And then that goes to a switch, which decides, okay, if it's a docx, then output the docx port. And so that goes and it uses an N8N node called extract from file, where you can choose from XML or PDF or rich text format or text files or whatever. I put in a case where it wasn't known and it would just extract the base64. I don't think that'll work because it's not going to be able to embed based on base64. So that's just probably not going to work. I think the better way would be, if it's unknown, that we throw an error or something and say, hey, this file type isn't known. Please, choose from PDF, CSV, XLSX. In the end, if you have a weird file type, you can still, as long as you can extract it to some sort of comprehensible form, then that can still go in here. You add your own code node. Maybe you need to add an external library, and it then can have external libraries added to it. If you add that into, I can't remember how to do it in Docker, but if you install N8N using npm and run it with Node, then you can install other npm packages in the same environment and export a variable with n8n that tells it you're allowed to use this and this and this npm library. So that if you need that, then you can put that in a code node and say, for example, like maybe you like use ffmpeg or something to extract information from videos, then that would be something you would do with a code node. Anyway, so what we're doing is trying to extract. I'm only testing PDFs, so I've set up the second step, which would actually need to be here for all of these, which is we pipe the data into a specific field. The text of the PDF is piped into a field called data, and I have another field called document ID, where I take the metadata document ID from the PDF, because I want to be able to know, okay, you got that document back, that this chunk of the document came back, which document does that actually refer to? Because once you vectorize, there's not necessarily any link back to the document that it came from. There's lots of metadata, but you might not have necessarily the document ID. There might just be the number of pages and the size or something like that, created date. But I want to take specifically the document ID because I'm going to pass it down later on into the metadata that's going into the vector store. So then we reach the vector store, which like I said, I'm using Qdrant. So you can set up your API key in Docker. It's part of the Docker compose file that you'll see if I have remembered to put the Docker compose file in the description. And again, it's an internal address, so it's Qdrant :6333, and it'll show you if it works or not. And it to do. Just select that collection from list, but I'm using by ID because if you put a name of a collection here that doesn't exist, then it'll create it for you. Now, I played around with this whole collection config thing to try to like tweak the configuration of the collection, but I got nowhere and it just threw errors all the time. The best results I've got is just leaving it alone and letting it do what it thinks is best. And connect an embedding model. The embedding model is which LLM, a specific LLM that's designed to create vectors out of text. You need to keep in mind that you should probably use the same LLM. In fact, you pretty much must use the same embedding model when you're storing the vectors as when you're retrieving them later. So if you choose Ollama here, then make sure you use Ollama in the retrieval part, in the RAG part. And why that is because the number of vectors changes depending on the model. So this one was made with, I can't remember what model. I think normally it did tell me. Was it here? This one was made with, I think it was this one. No, sorry, it's not. Never mind. There's some examples in Qdrant. If you want to check them out, you can download them and look through them. So there's like, really big data points with like, 100,000 vectors. And they're made with different Hugging Face models. So each one has its own vector size. So there's 384 vectors in every point that's put into this, and you can't mix it, or you can mix and match. Sorry, you can mix and match, but I haven't figured that out yet. So if Llama is putting in at 3072 vectors into, sorry, dimensions, not vectors, excuse me. I'm trying to get the language of this as well. Dimensions, there's 3072 dimensions when Llama 3.2 does the embedding. Whereas, for example, when I use the OpenAI Ada model, Ada 2, that was 1,000 and something dimensions. That means that if I use OpenAI here and then I use Llama to retrieve it, it won't retrieve it because it has to be the same number of dimensions. So that's why you either need the same model or like a very, very similar model. But even if the two models have the same dimensions, it's not necessarily true that the second model will be able to retrieve with the right precision as it would if you use the same model to retrieve. So there's a chance that you're going to reduce your the effectiveness of your retrieval if you use two different models. So anyway, use here Ollama. I have OpenAI here because I benchmarked them against each other. They seem to be, OpenAI ChatGPT 4.0 was definitely better than Ollama at retrieving and structuring the information that it retrieved in a very coherent and very detailed way. So you've got multiple variables. You've got how good is it at actually doing the vectors. You've also got how good are you at saying what the vectors should look like how should you chunk up the data, and should it be paragraphs or sentences or numbers of tokens, etc. So that's all to think about, and that's really just trial and error. So I would try one document, try it out, does it work? Try it a different way, does that work better? Did it come up with more precise information or not? But there's also the model you choose, is it really accurate? And then are you going to get that accurate result on the RAG side from that model? So there's a lot of variables involved. But here I'm just going to use Ollama because we're sticking with the open source example, but you could easily use OpenAI or any other embedding model that's available. We need to connect a document loader. So I'm just doing the default document loader. We're going to have JSON data coming in because I've used the end nodes to turn these different file types into JSON data. And we're going to load all input data, so the document ID and the data that came in. And we're going to add a metadata field, which is document ID, and we're going to put in that specific document ID that we took. So that could be the name of the document, it could be whatever. You could have several different fields. You could have document name, document created date, whatever you feel like you want to store with each vector, and that will come up here in the metadata. So you have the actual content and the metadata about each bit of content. So if you look down here, I think this is some French government thing. You have the data, and then you have the metadata about that. So the content is what the language model uses to structure its answer, and the metadata is for you if you want to debug, or if you need to know where the data came from, then that's for which you'll see in n8n in the RAG log. You'll see the metadata from each result that was used to make the chat assistant's answer. Okay, so that's good. And then you want to have a text splitter on there. The recursive character text splitter is quite good because it purports to cut things up into paragraphs or sentences depending on the length. So you put in a chunk size. So I have it set at 1,000. Did I have it? Yeah, it was set at 1,000. I think that's like the maximum chunk size in terms of characters, maybe? Can't remember. Either characters or tokens. And it will chunk smaller if it can, or it'll say, okay, this paragraph is like 700 characters long or tokens long, so I'm going to use the entire paragraph as a chunk. Chunking is important because if you chunk too big, then you're relying on the context window of the model being big enough to be able to suck in all that information and to be able to pull out specific parts of it. So if you're asking for one specific sentence and it's lost in like a page worth of chunk, then it might not be able to get that specific sentence out. Whereas if it was a smaller, like just one paragraph and you have one sentence of the paragraph, it's more likely to pull out that information and use it. So this is all set up good. We're going to, hang on, get back over here. There we go. We are going to run it. So I'm just doing the test workflow run thing to put the document in. I'm trying to remember, do I have that? So we're going to call this a new collection and we're going to call it cats, of course. Save that and we're going to run it. So it's going to find the file in the bucket, take the file, chunk it up. So it extracts it into, you can see like the info from the PDF, the metadata from the PDF, and the text. So there's a huge chunk of text, and that is now being converted. All the text has been chunked up, so we can see how that worked here. So there's what's that? Yeah, there's all the different chunks, so you can see that it's turned it into kind of paragraphs, and that has gone through the document loader, and so that turns it into the prepared data for the vectorization. So it has the page content that we saw. It's page content is a field that N8N uses by default. The annoying thing about this is that N8N is, I think N8N expects you to use their model to input the documents and to retrieve them, because if you use the quadrant default collections data sets that they have, it won't actually work for retrieval, because N8N expects it to have a field called page content and not content, so, or whatever it is that the difference is. So it doesn't correspond, and so if you want to set the system up, you would be best trying to do the embedding through N8N and the retrieval through N8N to make sure that it works properly, because it has its own structure that it kind of enforces with the document loader and all those things. So this is going to probably take a little bit of time, because it is actually quite heavy. So, oh no, there we go, 82 items, 87 items. There, my eyes are not good. Let's go back to our collections. There's cats, 87 items. It's gone 3072 dimensions, which is the llama one. And here we go with our chunks. So you've got chunks of data, and then the vectors are here, and you can go and see the vectors, and you can do all sorts of fun things like find similar, where it'll try to find paragraphs that are similar to this one, or look at the graph, and I think that does like similarity searches. So you can look for like your one, then something similar, and go for that one, and then look for something similar to that one, or similar to both of them. So it's all funky, cool math stuff that I don't really care about. Sorry, but yeah, so it's good. We're good to go. So that's done. Now we can forget about that for the moment and go back to our chat example. So I'm doing in N8N chat. I'm not using the webhook for the moment. Or I was actually in the other example I did before in a different video, but here today I'm just going to use the N8N built-in chat, which is great, and you can actually embed this in web pages if you want to, and then you don't have to write any front end. You do everything with N8N, no front end required, if you want to just have the chat window. I'm using the Ollama chat model to chat with, to take the input from the user and understand it. I'm using just a standard window memory buffer, so that's window buffer memory, so that's it'll remember what the user is saying in this particular conversation, but it won't remember if the user starts a new conversation or refreshes the page. I'm using a tool with this tools agent, which I've said that you're a friendly chat assistant and you'll be provided with information about cats. Sorry, it was a different example I did before. Your job is to find cat information and summarize it. Find cat information based on the user's request and summarize it for an easily understandable answer. To complete your task, this is just I'm trying to force it to do things. The consistency is a question here. Sometimes if it's left to its own devices, it'll 4 times out of 5 get a good answer, and 1 time out of 5 just say wrong answer format or didn't use the tool correctly or whatever. So to complete your task, you must restrict your answer to the response of the vector search tool, and I'll show you that in a second. The user may ask in French or in English. That was before, but well, we can try that just for fun. Because one of the things about vector searching that's really useful and interesting is that language ceases to be a problem, because it's not the words of like French or English or Spanish or Chinese Mandarin or whatever. It's the sense of the words that the language model understands all the different languages with the same sense. So the word in French and the word in English that means the same thing may have the same vector, vectorized value, so the same vector point. So we can do this for fun. And then, yeah, we don't need that part anymore. You must give your answer like the Pink Panther. That was just a little experiment that didn't actually work. It didn't give the answer like Pink Panther. I did Homer Simpson last time. That worked really well. Pink Panther didn't work at all. And maybe just doesn't know the Pink Panther. We don't need anything else here. That's perfect. You can also mess around with other options, but we don't need that right now. Vector store tool. So we give the tool a name, and then that corresponds to the name that I put in the instructions. You don't actually have to do this. Even if you don't mention the tool, it's a tools agent, so it will look for the tool and it will read the description of the tool and say, ooh, that corresponds to what the user said. So then I'm going to use that to output my answer, to get information, to retrieve information, to augment my generation. So that's RAG, Retrieval Augmented Generation. You can limit it to whatever, so limit it to 10 results if you think that that's all it'll take in general to get the answer, especially if you know that your chunk sizes are like a paragraph. Then maybe you don't want more than 10 paragraphs, because then that's going to be using up a lot of tokens or a lot of context. So again, it's just a variable to think about. Okay, my vector database is full of really long paragraphs, so maybe I should limit this to 5, because I actually don't need more than that to get the answer. Or you're looking for a really precise piece of information, so limit it to 1. You just want like the top piece of information and nothing else. You don't want the tool to be confused. And it's all trial and error. Just, keep setting the number differently and keep trying it. Keep chatting, refreshing, and just see what works best. This is really important. I messed this up at the beginning. The model that you put here, it gives you the choice between the Ollama chat model and the Ollama model, which I think is actually just like a more, the basic version, like not the GPT chat version, or whatever. I used this model and it didn't work at all. And then I switched it to the chat model and it worked like gangbusters. So put the chat model into the vector store tool. I wonder if this is maybe how it actually generates the answer that's going to come out in the tools agent answer. So that's why that's important to be a chat model. I tried it with OpenAI's chat model, that also worked, and it worked better. And then you need to connect your vector store. So we're using Quadrant. And so I have linked up the same Ollama embedding model with the same model 3.2 to make sure that it has the best chance of getting out the right information. That's not to say that you can't mix them up. Like I could say that maybe OpenAI, for example, OpenAI is super fast at embedding, way faster than Ollama. So maybe I actually want OpenAI to do the embeddings to increase the chance of getting a precise answer, but I don't actually need the agent to speak very coherently. So I'm happy just to use Ollama for the speaking with the client part, but for the actual retrieving of the information and translating that into coherent data for the model, maybe OpenAI is better. So I can actually mix and match, and that's part of this whole like LangChain concept, is mixing different LLMs together to do different jobs. You're already mixing an Ollama embedding model with an Ollama chat model. So we're already mixing two. You can mix as many as you want in certain cases. I think that's all you need to know to get that working. Yeah. Oh, so yeah, we're retrieving documents from list, and we select the collection that we want to retrieve some. So I don't want that anymore. I have to change to cats. That would have been embarrassing if that hadn't worked. You can also have search filters. So if you want to take it between a particular date range or something like that, or the customer is going to give a date, then they could also, put the date in here, for example. So that's good. I think that's probably okay. Just double checking. You must use this. Oh no, that's not good. You must use this tool when asked about cats. Could be simple like that. Maybe that'll work. So we'll keep it simple. And now what we're going to do is, first let's just ask a general question. Tell me about feral cats versus, what was it? Free-ranging cats. It's a very global question, so it's probably not going to find anything very specific. It'll just bring back the top 10 results that explain generally what it is to have a feral cat or a free-ranging cat. So you can see things ticking away in the background here. Tick, 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 tick. It's looking up looking up what's in the vector store. It's found some stuff. So it's found a whole bunch of chunks, 10 chunks, because we said it was limited to 10. And now the chat model is working on the results to be able to feed the tools agent. And like I said, you can see that the first chat model's already run. So that's what I'm assuming. This is just to comprehend the question and translate it into the correct prompts to get it where it needs to go. And then, okay, so that's outputted something. There we go. So it's outputted an answer that's gone back to the chat model, which is going to work on that, I guess, to reply to the user. And then we should have an answer to our question coming out there, which didn't appear here. That's okay. And the answer is feral cats are domestic cats that have been abandoned or released into the wild have adapted living outdoors, while free-ranging cats are domestic cats. So you could say, well, it might have known that just because that's part of its data set. Fair enough. You might be right. So let's ask it something really, really freaking specific. And it'll take a while, so I'll have to kind of talk over it because I don't know how to cut videos yet. I'm such a bad YouTuber. Let's go right in the middle of the document and ask it something really weird. Trapping describes cage traps, folder traps, and body gripping traps. Okay. So we're going to say, we're going to refresh that. I'm going to refresh it because the context window is not very big for Olama, I don't think. So I would rather save and refresh, and we'll start fresh. So we're going to ask, what are the best trapping methods and rules? What trapping methods and rules should I know about for what was it, free ranging cats? Free ranging cats. So it should be telling us something about cage traps, filter traps, body gripping traps. It should be telling us that it varies by state, but we have to consult local laws before using traps. So will it give us this kind of information? I don't know. Well, we can have a look and see how it's doing. So it has already got the information back, and we can kind of get an idea if it's found something right or not. So let's just have a look here for trapping. So it has found something, which is funny that it was the 6th result. And this is something that I found with the other example I did for a client there about training courses that I showed you, French and English. It did actually come up with a lot of results that weren't to do with that, but I mean, this looks like it should be good. Let's see what it says. Do we see it in the chat window? Yeah. When trapping free ranging cats, it's essentially cage traps with regular checks up to 24 hours apart to ensure all carcasses are recovered after each trap. Non-toxic bullets should be used. What the hell? Bullet. Oh, there we go. The use of non-toxic bullets is recommended to prevent scavengers from exposure to lead. But that's in shooting though, it's not in trapping. So it's kind of a bit of an overlap there. Regulations vary by state, so consult. Look at that. Consult local laws before using any traps. Consult local laws and regulations prior to using any traps. It's just amazing. So, you know, it didn't quite get, I mean, maybe this isn't organized by probability either. Maybe this isn't like number 1 is the most likely. Maybe it just found exactly what it needed in result number 6 here. And proxy information, maybe this is stuff that's like quite near. So this is line 497, this is line 54, it's really far away. So no, I'm totally wrong. It's all really far away. And it doesn't seem to have anything to do with it if you look at it like. So probably if we compared this to OpenAI, it would actually do a better job. I'm not going to do that now because I'd have to go back and I'd have to re-vectorize the document with OpenAI embeddings and then come back here and redo the question. So we're not going to do that now. But I can guarantee you the answer would have been more precise with OpenAI. But still, the fact that I'm on a fully open source 2 gigabytes of RAM and I've managed to get a pretty precise answer, 2 pretty precise answers, like one global one that I'm sure if we searched we would find things in here. Like, what's this? Trap, neuter, return. Trapping and neutering programs such as trap, neuter, return. What the hell is that? Trap, neuter. It's a lot of neuter results. Neuter cats, trap, neuter, release. Okay, kind of messed that up. Such as contraceptive and trap, neuter, release, aim the limit. So it's returned something very precise, but it's just kind of made a bit of a mess of it. Don't think there's anything else in here about that. Trap, neuter, release again. It's mentioned here. Oh, no, there we go. There is something about trap, neuter, return. So it must be in there somewhere. Oh, that could also be part of its general data set. But I mean, we can say for pretty dang sure this has come from the document because we've just checked it, and we can say that that's so a mix between things that are from the maybe the data set. I mean, it did still have results from the document that it used. So at all points there will be 10 points coming through here that will go into the agent and be used depending on their probability of being close to the question. So there will always be something from the document being used, but is it mixed with information from its data set? I don't know. But still, you can just kind of, again, I'm not going to go back into it, but just put your mind to the task of what could I use this for? It's not just PDFs, it's Excel, it's Word docs, it's CSVs, it's JSON from APIs, it's huge database of cats from a JSON cat database, or I don't know, whatever, but like millions of results, and you take that JSON as a file and then use that as the text that you're actually vectorizing, and it could be a MongoDB NoSQL style thing where each of the objects in the collection in the JSON is a bit random and different, and there's no specific structure to it. Or you've transcribed audio or video, or you've done some image analysis and you're doing image embeddings, which you can also do if you have images. You can get specific models to do image embeddings. So just, anything can go in here, and then that becomes your AI agent, and then you just take that chat, embed it into your website, and you have saved yourself 5 phone calls a day, and just, we're on the precipice of something. So I really hope that this has given you a good basis to go on to start doing your own vectorization, experimenting with it, trial and error. I'm at the beginning. I've only just got it working properly tonight, so I wanted to share it with you guys, and it's really exciting. And I hope you get in there. Don't get discouraged. If there's any particular little bits that you're getting stuck on, put a comment on the video and I'll try to help you out. And I hope to see you in other RAG creation videos in the future. So that'll do for me, and I hope you enjoyed it, and see you in the next one.